Dr. M. P. Jayaraman is an assistant professor in mathematics in L.N. Government College, Poneri. He has specialized on geometric function theory. With 14 years of teaching experience, he has handled topics on probability and queuing theory, discrete mathematics, random process, and engineering mathematics. Being a recognized supervisor for guiding PhD and MS students of Anna University, he is the reviewer of the journal Computer Mathematics and Applications. He has also written books on discrete mathematics and has also published papers in 28 international publications, in 4 national publications, and has presented papers in 2 international and in 2 national conferences.
Welcome you all for UGC lecture series in mathematical sciences. In this session, we are going to construct a critical path for the given network scheduling. For a given network scheduling, we are interested in finding the longest path time, namely critical path. For that, we need certain time calculation. For each and every activity, we have to calculate the earliest starting time and latest starting time. So, for a given network, first we calculate the earliest time and latest time. With the help of this latest and earliest time, we are going to construct critical path for the given network problem. First, let me define what is earliest starting time. Suppose consider 0 is the starting time of a project. The project starts at 0 time. Then earliest starting time of each activity is the earliest possible time at which each activity starts. The earliest possible time when the activity can begin, assuming that all of the predecessor are also started at the earliest time. So, the earliest starting time is the earliest possible time which an activity starts. The earliest starting time of the activity I to j is denoted by ESI. So, ESI is the earliest starting time of all the activity emanating from the node I. So, for the activity I to j, the earliest starting time is ESI. The next idea is the earliest finishing time of an activity, which simply denoted by EF. The earliest finishing time of an activity is the earliest starting time of the activity plus the estimate time of that activity. So, for an activity, the earliest finishing time is the earliest starting time of the activity plus duration of that activity. Thus, if ESI denotes the earliest starting time of all the activities emanating from the node I and Tij is the estimated time of the activity Ij, then earliest finishing time of the activity is denoted by EFI or ESJ is nothing but the maximum value of ESI plus Tij. So, for all the defined activity Ij. So, for an activity Ij, what is the earliest finishing time? We name it as ESJ, which is nothing but the earliest starting time of that activity which emanated from the node I plus the normal time, the normal duration of the activity, which is Tij. So, ESI plus Tij is the earliest finishing time of the activity I to j. Here, for any activity, if more than one preceding activity is there, in such a case, the earliest finishing time is nothing but maximum of this one. So, the earliest finishing time is maximum of earliest starting time plus estimated time of that activity. So, with this earliest time, starting time and earliest finishing time, the next idea is latest start time, which simply denoted by LS. Suppose we have a target time for completion of the project. So, the target time for the completion of the project is the latest finishing time of the final activity of that network. So, let us keep the target time of the project in mind, then latest start time is the latest time at which an activity can start if the project target is to be maintained. So, the latest start time is by keeping the project target time, the latest start time is the latest time at which an activity starts its work. The latest start time is denoted by LSI. So, LSI is the latest start time of all the activity emanating from the node I. The next idea is latest finishing time, which we denote it as LF. So, latest finishing time of the activity is the latest starting time of the activity minus the estimated time of that activity. For example, if LSI is the latest start time of all the activity emanating from the event I and Tij is the estimated time of the activity Ij, then LSI is minimum of LSJ minus Tij for all the defined Ij activities. So, in this relation, if LSJ is the latest finishing time of the activity Ij, for the activity Ij, the latest finishing time is LSJ. For the activity, the normal estimated time is Tij. So, if we subtract the normal estimated time from the latest finishing time, we will get the latest starting time, which we denoted by LSI. If this activity has more than one predecessor, then in such a case we will take the minimum value of this LSJ minus Tij. So, the latest starting time is calculated from the latest finishing time with the help of this formula LSI equal to minimum of LSJ minus Tij. So, with this idea of earliest starting time, earliest finishing time and latest starting time and latest finishing time, we will try to compute the latest and earliest time for each and every activities. With the help of this earliest and latest time, we try to construct the critical path for the given network diagram. Problem: compute the earliest start, the earliest finish, the latest start and latest finish of each activity of the project given below and determine the critical path of the project. So, our project consisting of 6 activity 1 to 2, 1 to 3, 2 to 4, 2 to 5, 3 to 4 and 4 to 5. For each activity, duration in days are given. So, in order to determine the critical path of the project, first we need the earliest and latest starting and finishing time of each and every activity. For that, first we have to construct the network. So, the activities are given 1 to 2, 1 to 3, 2 to 4, 2 to 5, 3 to 4 and 4 to 5 and the corresponding duration is given. First, let us construct the network for the given activities. So, activity 1, 2 and 1, 3 is there. So, 1 to 2 an activity and 1 to 3 an activity. Then 2 to 4, 2 to 5 and 3 to 4. So, 2 to 4 there is an activity. So, 2 to 4 there is an activity. Then 2 to 5 there is an activity. So, 2 to 5 there is an activity. Then 3 to 4 there is an activity, we will connect 3 and 4. Then 4 to 5 there is an activity, we connect 4 and 5. So, the activity 1 to has duration 8 days, the activity 1 to 3 has duration 4 dash, the activity 2 to 4 has duration 10 days, activity 2 and 5 the normal time is 2. So, for activity 2 and 5 the normal time is 2. The activity 3 4 the duration is 5, activity 3 to 4 the duration is 5, then activity 4 and 5 the duration is 3. So, for the given problem we construct a network diagram which has a duration in days is given. Now, with the help of this network diagram we can estimate the earliest time and latest time. Network diagram has drawn neatly here. Now, for this diagram for each and every node we have to calculate the earliest time. We know very well the starting time of a project is 0. So, for the node 1 the earliest starting time is 0. Now, for the activity 1, 2, it takes 8 days. Therefore, earliest starting time for this node 2 is 8. Now, consider the activity 1 and 3, which has no predecessor. Therefore, for the activity 1 and 3, the earliest starting time is 4 only. Now, consider the activity 3 and 4. For the activity 3 and 4, there are two predecessors. One is 1 to 3 and 3 to 4. For the activity 3 to 4, the predecessor is 1 to 3. Therefore, one path is 1 to 3 and 3 to 4. So, 1 to 3 and 3 to 4. Next, for the activity 3 and 4, one more preceding activity is 1 to 2 and 2 to 4. So, for the activity 3 4, one more path is 1 to 2, 2 to 4. So, 1 to 2 and 2 to 4. So, for the activity 3 4, there are two predecessors, 1 to 3 and 3 to 4, 1 to 2 and 2 to 4. If we consider this path 1 3 and 3 4, the earliest time is 4 plus 5 9. So, if we consider this path 1 2 3 3 to 4, the earliest starting time for the activity 3 to 4 is 4 plus 5 9. If we consider this path 1 to 2 and 2 to 4, then its duration is 8 plus 10 18. So, among these two, the maximum value is 18. Therefore, for the activity 3 to 4, the earliest starting time is 18, because in order to complete this activity 3 4, either 1 2 2 4 should be completed or 1 3 should be completed. Among these two, the maximum is 18. Therefore, earliest starting time for the activity 3 4 is 18. Now, we have to compute the earliest starting time for the activity 4 and 5. So, for the activity 1 and 2, earliest starting time is 8, and 1 3 it is 4, and 3 4 it is 8. Now, with the help of this earliest starting time, we can compute the earliest finishing time for the activity, which is nothing but earliest starting time plus the estimated time. So, this is the formula for earliest finishing time of the activity. Now, the project completion time is the earliest starting time plus normal duration. Therefore, for node 5 it is 18 plus 3 21. So, for each and every node we will got the earliest starting time and earliest finishing time. Now, we will try to compute the latest starting time and latest finishing time for this network. The latest finishing time for the final node is the total completion time of the project. Therefore, for the final node 5, the latest finishing time is the total completion time of the project, which is 21. Now, for the node 4, the latest finishing time we have to calculate. Now, for the node 4, the latest finishing time is 5, here 21 minus 3, which is 18. So, for the node 4, the latest finishing time of the node 5 is 21. So, 21 minus 3 18. Now, for the node 2, we have to calculate latest finishing time, and for the node 3, we have to calculate the latest finishing time. Now, for the node 2, there are two paths. One is 2 to 5, one activity is there, then 5 to 4, 4 to 2 is there. From this, we have to take minimum. So, 21 minus 2, which have 19, and here 18 minus 10, which is 8. Therefore, the minimum among these two is 8. Therefore, latest finishing time for node 2 is 8. Then latest finishing time for the node 3 is 18 minus 5, which is 13. For the node, the latest finishing time is 18. So, 18 minus 5 13. Now, for the starting node, the latest finishing time is the starting time of the project, which is 0. So, in this network diagram, for each and every node activity, we calculated the earliest time and latest time. Next problem is calculate the earliest starting time and earliest finishing time and latest starting time and latest finishing time of each activity of the project given below and determine the critical path of the method. So, our problem consisting 10 activities. For each and activities the normal durations are given. Now, in order to construct the critical path for this project, first we construct a network for the given problem. So, in this problem the activity 1, 2, 1, 3, 1, 5 is there. Therefore, the network is 1 to 2, 1 to 3 and 1 to 5. The duration for 1 to 2 is 8, the duration for 1 to 3 is 7 and the duration for 1 to 5 is 12. Next, activities 2, 3 and 2, 4. So, the activity 2, 3 is there, which takes 4 time units, and 2 to 4 each take 10 time units. Next, 3 to 4 it takes 3 units. So, 3 to 4 3. So, this is over. Next, 3 to 5. So, 3 to 5 5 durations. The next activity is 3 to 6, 4 to 6 and 5 to 6. So, the next activity is 3 to 6, which consumes 5 hours, and 4 to 6 which takes 7 units and 5 to 6 which takes 4 units. So, for the given problem the network is this one, the activity 1 2, 1 3, 1 5, then activity 2 3, 2 3 is there, then activity 2 4, then activity 3 4, activity 3 4, activity 3 5, then activity 3 to 6, activity 3 to 6, activity 4 to 6 and activity 5 to 6. So, for a given problem the network is this one. Now, with the help of this network we can compute the earliest starting time and latest finishing time. For this network diagram the starting node is 1, therefore, earliest starting time is for this node is 0. Now, for the node 2 the only activity is from 1 to 2 only, therefore, for node 2 the earliest starting time is 0 plus the normal duration 8. Now, for node 3 the predecessor activities is 1 to 3, that is one thing, another one is 1 to 2 and 2 to 4. So, for the node 3 the earliest starting time E is the maximum of 0 plus 7 via 1 to 3 or via 1 to 2 and 2 to 3, therefore, 8 plus 4 12. So, among these two maximum is 12, therefore, earliest starting time for the node is 12. Now, the earliest starting time for the node 5 is only one activity 1 to 5. For 1 to 5 it is 12. Now, for 5 the another one is 1 to 3 and 3 to 5. So, which takes 12 plus 5, therefore, 17. Now, for the node 4 the predecessor activity is 1 2, therefore, 1 to 2 4, therefore, the earliest starting time for the node E is 10 plus 8, which is 18. Now, for the node 6 we have activity 4 6, 4 6 is one activity and 3 4 3 6 is another activity and 5 6 is another activity. Now, for this activity 4 6 predecessor is there, for 3 6 predecessor are there, for 5 6 predecessor are there. Therefore, for this node our earliest starting time is, if we come via 4 6 it is 18 plus 7 25, and if we choose 3 to 6, it is 12 plus 10 22. So, via 3 6 it is 12 plus 10 22, and if we take this one 5 to 6, it takes 4 normal duration, therefore, 17 plus 4 21. So, among this maximum is 25, therefore, for the node 6 the earliest starting time is 25. Now, for each and every activity, now we have to compute latest finishing time. We know very well, for the final node of a network diagram, the latest finishing time is the completion time of the project. Therefore, the latest finishing time for the node L is 25. Now, for the node 5, there is only one path from 5 to 6. Therefore, the latest finishing time for the node 5 is 25 minus 4, which is 21. Now, for the node 4, the latest finishing time is via this path only 4 to 6, which is 25 minus 7, which is 18. Now, for the node 3, we have to compute the latest finishing time. For the node 3, the latest finishing time is as follows. For the node 3, there is an activity from 3 to 4, and there is an activity from 3 to 6, and there is an activity from 3 to 5. So, if we come backward from 6 to 3, the latest finishing time is 25 minus 10 15, and if we come from 4 to 3, the latest finishing time is 18 minus 3 15, and if we come through this way, the latest finishing time is 21 minus 5 16. Among this, the minimum is 15, therefore, the latest finishing time for the node 3 is 15. Now, for the starting node 1, the latest finishing time is the starting time of the project 0. Now, for node 2, the latest finishing time is via 2 to 4. If we come backward for this activity, for node 2, the latest finishing time is 18 minus 10 8. So, for the given network, for each and every node, we calculate earliest starting time and latest finishing time. Now, with the help of this earliest starting time and latest finishing time, by making use of the table, we can compute the earliest finishing time and latest starting time. So, our problem has the activities 1 to 2, 1 3, 1 5, 2 3, 2 4, 3 4, 3 5, 3 6, 4 6 and 5 6. These are the activities we have, and the duration for each activity is given. For the activity 1 to 2, duration is 8, 7, 12. For 2 3, it is 4, it is 10, 3. For activity 3 5, it is 5. For activity 3 6, it is 10, 4 6 7 4. Now, we calculate earliest time for each and every activity. In earliest, we have earliest starting time is there and earliest finishing time is there. Now, through our network, we calculated the earliest starting time for each and every activity. Now, for the activity 1 and 2, the earliest starting time for the node 1 is 0. Here also 1 3 in starting node is 0. For 1 5, the starting is 0. Next, for the activity 2 3, the start node is 2. For the node 2, the starting time is 8. So, for this starting time is 8. For 2 4, the initial node is 2, therefore, starting time is 8. Now, for the activity 3 4 and 3 5 and 3 6, the starting node is 3. For the node 3, the earliest starting time is 12. Therefore, for this, the starting time for 3 4, 3 5 and 3 6 are 12. Now, for the activity 4 6, the starting node is 4. For the node 4, the earliest starting time is 18. Now, for the activity 5 and 6, starting node is 5. For the node 5, the earliest starting time is 7. Now, for each and every activity we can calculate the earliest finishing time. The earliest finishing time is the earliest time of this activity plus duration. Therefore, for the activity 1 and 2, the earliest finishing time is 8 plus 0, which is 8. Now, for the activity 1 3, 7 plus 0 7. The same way for the activity 1 5, the earliest finishing time is duration of that activity plus earliest starting time of the activity, which is 0. So, 12 plus 0 12. In the same way for the activity 2 3, the earliest finishing time is the duration of the activity 4 plus the earliest starting time of the activity, which is 12. The same way for each and every activity, by adding the duration of that activity and starting time, we can obtain the earliest finishing time. So, for the activity 3 4, which is 15, for 3 5, which is 17, for 3 6, it is 22, for 4 6, it is 25, and for the final activity 5 6, it is 21. The latest finishing time for each and activity, we have starting time and finishing time. Suppose for the activity 2 and 3, the final node is 3. For the node 3, already we calculated the finishing time. So, for node 2, the finishing time is 8. For the 1 3, the finishing time is 15, which is 21 and 15, 18, 18, 21, 25, 25, 25. So, for each and every activity, for the final node already we calculated latest finishing time. For the activity 1 2, for the final node 2, the latest finishing time is 8. Now, from the latest finishing time, if we subtract the duration, we will get the latest starting time for that activity. So, 8 minus 8 0. So, for the activity 1 2, the latest starting time is 0. For example, for the activity 3 and 5, the total finishing time is 21 and the duration is 5. So, if we subtract 5 from 21, we will get 16 as the latest starting time for the activity 3 and 5. In the same way, for each and every activity, the latest starting time for 1 2 is 0, 1 3 is 8 and 1 5 is 9 and 2 3 is 11, 8, 15, 16, 15, 18 and 21. So, for the complicated networks, with the help of this table, we can compute the earliest finishing time and latest starting time. Let me recap of the points. The earliest starting time is the earliest possible time in which activity can start, and latest finishing time is latest starting time of an activity minus estimated time of that activity. Question: a project consists of the following activities and time estimate. For this activity, draw the network, determine the earliest starting time and latest finishing time, obtain the critical path. Thank you.